Good morning, Pre-Algebra. Welcome to your first online lesson. Today's lesson is going to be 8.8, Systems of Linear Equations. I have just learned that the maximum recording time I have on the free version of this program I'm using to record your notes is only 15 minutes. I have no idea how long I was talking after the recording stopped, so we're starting over. And I'm going to be moving a little more quickly. However, the beauty of YouTube is that you can pause at any time. Pause the video at any time. Pause and rewind. Just like you sometimes may not understand when I explain this to you in person, you may not understand the first time you watch this video. So do not hesitate to stop the video and go back or watch it more than once. The goal of today's lesson is to graph and solve systems of linear equations. We have two vocabulary words, system of linear equation and solution of a linear system. So a system of linear equations is simply just two or more equations being graphed on the same plane. The solution of a linear system is the coordinate on the plane that makes both of the equations true. So we're going to see in example 1 how to identify the solution of a linear system. We are going to be solving by graphing. So the first step for me, for my class, is to pick a color for both of your equations. So equation number 1 will be yellow and equation number 2 will be green. So we are graphing the equations. Yellow, equation number 1, y equals x minus 3. Isn't it great that these are already in slope-intercept form for you? The y-intercept is -3. The slope is 1 over 1, so rise 1 up, run 1 to the right. And you are going to keep doing that all the way to the end of the graph. You need to really focus on making sure your lines that you're graphing are very, very accurate, because that is the only way you will be able to identify the answer. So accurate, in fact, that I am going to go back to the y-intercept and I'm going to reverse the operation and I'm going to go down 1 to the left 1 to make my points go all the way through the graph. And I'm going to draw my line. And there we go. Equation 2. The y-intercept is +3. So we are going to be up here on the y-axis at 3. And our slope is -1/5. So I am going to go down 1 to the right 5. 1, 2, 3, 4, 5. And I can't go anywhere else. I have no more room on this coordinate plane, so I am just going to draw the line. I'm going to draw a more accurate line. It won't erase, so never mind. There we go. I think that was less accurate. Okay. So we graphed the equations. The next step would be to identify the intersection point. Identify the intersection point. So where do these two lines intersect? They intersect right here. The coordinate is 5, 2. 5, 2. This is your x value. This is your y value. We need to verify that the coordinate 5, 2 is actually the solution of the system. So step 3 is your check step. Check for step 3. It is very important. So you are going to substitute the value of x, which is 5, and the value of y, which is 2, into both of your equations. So starting with equation 1, I'm going to substitute 2 for y and 5 for x. Bring down the 2. We don't know whether or not they're equal yet, and then we're going to do 5 minus 3. 5 minus 3 is 2. So 2 does equal 2, and the coordinate that we found on the graph does work for equation 1. It is true. But the key to systems is that the solution needs to be true for both or all of the equations in the system. So before you can confirm whether or not it's true, you must check equation 2. Equation 2. We're going to plug in 2 for y. And I do not like that they used an x here for multiplication, so I'm just going to cover this up with nice parentheses, and we're going to plug in our value of x, 5. I'm sorry, the cat is attacking my curtains. All right, 2. Bring down your 2. We do not know if it equals or not. We have negative 1/5 times 5. Negative 1/5 times 5 is negative 1. Negative 1 plus 3. Negative 1 plus 3 is 2. So 2 does equal 2, and this one is also true. That means the coordinate that we found as the solution, 5, 2, is correct. It is the solution. We are good. That is the answer to the system. All right. Let's do some practice problems. What I would like you to do is pause this video and do a checkpoint problem. Then unpause the video, check, and identify your errors if there are any. Pause the video again. Do the second checkpoint problem, unpause, and check for any errors or check your solutions. All right, checkpoint number 1. These equations in this system are both already in slope-intercept form, so you are ready to go. I recommend labeling equation 1 in one color and equation 2 in a different color. All right, equation 1. Y equals negative x plus 3. We're going to start at our y-intercept, 3, and our slope is negative 1. So we are going down 1 to the right 1. And we're going to keep going to the edge of the graph. Go back to your y-intercept and reverse the slope. Go up 1 to the left 1 so you can hit both edges of the coordinate plane so we can make sure our line is going to be accurate. Equation number 2. The y-intercept is negative 1. Our slope is 1/3. Rise 1. Run 3 to the right. Back to your y-intercept and do the opposite. Rise down 1 and run to the left 3. So you can fit as many points as possible on your graph. I'm just going to draw a line through that. Step 2, identify the point of intersection. I found it. I'm going to turn it green. What is the point of intersection? 3, 0. The point of intersection is 3, 0. So now you must check. To make sure that this is actually the solution. So you're going to go back to equation 1. Back to equation 1, and you are going to plug in the x and the y into your equation. So 0 equals -1 times 3 plus 3. 0 equals -3 plus 3, and 0 equals 0. So 3, 0, the coordinate 3, 0, is a solution to equation 1. Equation 2. We're going to plug in 0 for y equals 1/3 times 3 for the value of x minus 1. 0 equals 1/3 times 3 is 1. 1 minus 1 is 0. So this is also a solution. So that means the solution is definitely 3, 0, and it is correct. Checkpoint number 2. We're going to move over to checkpoint number 2 because this one does not have two equations that are in slope-intercept form. So the first thing you need to do is put them in slope-intercept form. And I am running out of time on this video, so I am going to pause and put these in slope-intercept form. All right, here we are with these two equations now in slope-intercept form. What do you notice about these two equations that are now in slope-intercept form? Did you notice anything? Did you graph them yet? All right. Let's graph the first equation, equation number 1. The y-intercept is -3, and the slope is -5/1. Well, I can't rise down -5 because I am out of room. So I am going to go up and to the left. 1, 2, 3, 4, 5, and 1. That's my first line. My second equation starts at +4, and this time I can go down 5 to the right one. 1, 2, 3, 4, 5/1. Hopefully some of you noticed that these two equations do have the same slope. And we know that equations with the same slope will graph parallel lines. And we also know that parallel lines do not intersect. So if the solution is discovered by graphing at the point where the two lines intersect, that means that parallel lines have no solution. Parallel lines have no solution. I paused the video really quickly to give you a second example. Infinite solutions. So you have one solution, equations with lines that intersect. Now you have no solution, parallel lines, and the last one would be infinitely many solutions. That would mean the two equations would have to give you exactly the same line. So our first one is y equals 2x plus 5. Our second equation in yellow is not in slope-intercept form. So quickly divide by 2 on both sides, and you are left with y equals 2x plus 5. Now they are the same equation. If you were to graph these, they would be on top of each other. infinite solutions. All the points are an answer. Head over to my next video for more examples.